We are on home pages, page 130. We are on number 3, using the doubling and halving to fill in the blanks. So if you look 5 1/4 times 12, you see 6 over here. So you know that 12 and 6 have a relationship. So if you take 12 and you half 6, so then you know you need to double 5 1/4. So 5 1/4 doubled is 10 1/2. And so you can go ahead and multiply 6 times 10, which is 60. 6 times 1/2, which is 3, and then your answer is 63. You use the doubling and halving strategy to make your problems easier for you to do. 16 times 3 1/2, you know that the 16 and the 8 have a relationship. 16 to 8, it's broken in half, so you're going to double the 3 1/2, so you double 3 1/2 to get 7. 8 times 7 is a lot easier than 16 times 3 1/2, so 8 times 7 is 56. They've made the blank the first answer this time, so we're going to look at the 18 times 9 and see the relationship there. So I know that 18 doubled is 36, so then I have to have the 9. 9 divided by 2 is 4 1/2. I'm going to go ahead and multiply out the 18 times 9, which is 162. The next one, 3 1/3. You're noticing that that is half of 6 2/3. So then you're going to want to double your 15. So 15 doubled is 30. 30 times 3 is 90. 30 times 1/3 is 10. Add them. 90 plus 10 is 100. Moving on to number 4, we've got a birthday card that Adam made for his sister. The card is 6 1/2 inches by 9 1/3 inches. What is the area? It says make a labeled sketch to model and solve this problem. When you find area, you know you're going to do the length times the width. So you're doing 6 1/2 times 9 1/3. Go ahead and make your sketch. 6 broken up and then 9 broken up between their fractional parts. So the first box is 9 times 6 is 54. 9 times 1/2 is 4 1/2. 1/3 times 6 is 2. And then 1/3 times 1/2 is 1 1/6. You add them up together, your final answer is going to be 60 2/3 square inches. Because you're doing inches times inches, your label is going to be square inches. If you wanted to turn this one improper, you could have done 13 over 2 times 28 over 3. Now I'm noticing 13 times 28 is going to be really difficult, so I hope that I can cross cancel. 13 and 3 do not have a factor in common, but 2 and 28 do. So I'm going to divide them both by 2 because they're even. 2 divided by 2 is 1. 28 divided by 2 is 14. Now I'm going to go ahead and multiply this out. So 13 times 14 is 182. And then 1 times 3 is 3. 3 goes into 182 60 times with 2/3 left over. Square inches. Number 5, we have to convert the fractions to decimals. So 8 over 10, you can say 8 tenths. Tenths is the first place value after the decimal, so it's going to be 0.8. 3/4, you can think of it as quarters or money. It's the same as 75 cents, so 0.75. 4/5 is a little bit trickier. You could think of money, and 1/5 of a dollar is 20 cents. So if you have 4 20 cents, you're going to get 80 cents, which would be 0.8. You could also multiply them both by 2, the numerator and the denominator, and if you multiply them both by 2, you're going to get 8 tenths. And so 4/5 is the same as 8 tenths, 0.8. The next one, fifths again, you know that 1/5 is 20 cents. And if you have 6 20 cents, you're going to have $1.20. So 1.2 would be the decimal. Number 6, this challenge is kind of fun. We've got a sack of jelly beans with 5 different colors. half of them are red, 1/6 of them are green, 1/6 are yellow, 1/12 are orange, and 6 are black. How many of each color did Justin get, and how many jelly beans were in all? So in order to do this, I'm going to start with a sketch. I'm going to sketch one hole, and that will help me determine how many jelly beans there are total. I'm going to go up here, half are red, so I'm going to take my hole and I'm going to divide it in half, and then this is going to be the red portion. 1/6 were green. So if this is 1/2, I know that if I divide this into thirds, and then if you also divided these up, that would be 6 parts. So one of those parts are green. 1/6 are yellow. So that's going to be yellow. And then 1/12 were orange. So I'm going to break this last 6 into half. And that's going to be 1/12. This is going to be orange. And then 6 were black. So the last part that I have left, this is going to be the black. And I know that there's 6 there. So if I know there's 6 black, there's also going to be 6 orange. I was going to write this over here. Orange is 6. Then yellow makes up both the orange and the black. So 6 plus 6 is 12. So the yellow is going to be 12. I guess I should have put in the black here, even though they already told us black is 6. Green is going to be the same as yellow. And then if you add up this whole half over here, that's going to equal the red. So 12 plus 12 plus another 12 is going to be 36. So the red's going to be 36. And then the total, add them all up. 36 plus 36 is 72 total jelly beans. Moving on to page 131, the Unit 6 review, you can see some diagrams. Down here you've got your trapezoids and you've got your not trapezoids. List 3 properties of a trapezoid, and some of your answers could have included a trapezoid has 4 sides, a trapezoid has exactly 1 pair of parallel sides. You can see that up here. A trapezoid has 4 corners. Corners are also called vertices. A trapezoid has 4 angles. A trapezoid is a quadrilateral. And a trapezoid is a polygon. So any of those answers could have been correct. Number 2, fill in the bubbles besides all the other names you could use for a trapezoid. A trapezoid could also be a quadrilateral. A trapezoid cannot be a rectangle. A trapezoid cannot be a triangle, but it can be a polygon. So the 2 correct answers are quadrilateral and polygon. Number 3, why can't a trapezoid be a parallelogram? Well, one of your answers, if it's close to this, could be a parallelogram has 2 pairs of parallel sides, and a trapezoid only has 1 pair of parallel sides. That is the main reason why a trapezoid cannot be a parallelogram. Number 4, while playing the polygon search game, which we did not learn, but that's okay. We can still answer this question. Shayna graphed the points 1, 2, 4, 2, 4, 5, and 1, 5. And we graphed them on here. And then the shape that she drew is a square. It says list 2 properties of this shape. So some things that you could have included is there's 4 congruent sides in a square. Squares have 4 right angles. A square is a rhombus. A square is a parallelogram. A square is a quadrilateral. And a square is a polygon. So those could be any of the 2 properties you could have listed. Number 5, Cooper and Luke made a sequence with their tiles and then they graphed them on the same grid. List the 5 ordered pairs of Cooper. Well, over here we can see Cooper is the X. So the first one was 1, 2. The second one is 2, 4. The third one is 3, 6. The next one is 4, 8. And then the last one is 5, 12. The x value is the arrangement number, and then the y value is the number of tiles. So if you look at his sequence, the first arrangement had 2 tiles, his second arrangement had 4, third arrangement had 6, and so on. Then Luke's is going to be 1, 1. So his first arrangement had 1 tile. The next one's 2, 2. Second arrangement had 2 tiles. 3, 3, 4, 4, and 5, 5. For C, it says, what can you tell about the tile sequences from looking at the graph they made? Fill in the bubbles besides all of the correct observations. Cooper used twice as many tiles as Luke did in each arrangement. So the tile number is the Y. Okay, so we're looking at the Y. So the first one, Cooper used 2, Luke used 1. Cooper used 4, Luke used 2. 6, 3, 8, 4, 10, and 5. So that one is correct. The second one, Cooper started with 3 tiles and added 2 more tiles for each new arrangement. That one is false. Cooper did not start with 3 tiles. Cooper started with 2 tiles. Luke's third arrangement had 6 tiles. Well, if you look at Luke's third arrangement, the Y value is a 3, so that one is not correct. There would be 12 tiles in Cooper's sixth arrangement. So if he's adding 2 each time, the next arrangement would be 6, 2, 12, I mean. He added 2 to make 12, so that one would be correct. On number 6, we've got a box that's 3 feet wide, 5 feet long, and 8 feet high. What is its volume? So you know we need to do length times width times height. So 3 times 5 times 8 would get you an answer of 120 cubic feet, or you could have said feet cubed as your label, but don't forget that label. Number 7, we've got a school container with a base that's 7 by 7. The volume is 343. What is the height? So you know that you've got your length times your width times your height. We know equals the volume, and the volume is 343. So we're trying to find the height because we know one is 7, another is 7, and then we don't know the height. So you need to take 343 and divide it by 49. So if you take 343 and divide it by 49 using your strategies, your final answer will be 7. So the height of the container is 7. And then the last one, it asks, what is the shape of the container? Well, if you know that each side is 7, it's a 7 by 7 by 7, it's all the same. Your answer is going to be a cube because all of the dimensions are equal.